Let us look at the next problem then. We have the next problem 2 to the power n plus 1 plus 2 to the power n minus 1 divided by 2 to the power n plus 2 to the power n plus 2. Now, what we can observe here is the repetition of the same base, right? We can observe the repetition of the same base, but they are repeated with respect to the positive signs. So here we need to be little careful. Here the repetition is with respect to the positive sign. So what we can do here is 2 to the power n plus 1, I can split and write it as 2 to the power n into 2 to the power 1 plus 2 to the power n minus 1, I can write it as 2 to the power n into 2 to the power minus 1 divided by the denominator, that would be 2 to the power n plus 2 to the power n into 2 to the power 2. We have split the base with respect to the powers. Now, if I concentrate on the numerator, I can see that 2 to the power n is common. So let me take that 2 to the power n common out. So if I take 2 to the power n common out, what remains is 2 to the power 1 plus 2 to the power minus 1 divided by, from the denominator once again I can take 2 to the power n common out. What remains is 1 plus 2 to the power 2. Here 2 to the power n, 2 to the power n cancels. That would be 2 plus 2 to the power minus 1 negative power. I can write it as 1 by 2, that is nothing but taking the reciprocal of the base. So all divided by 1 plus 2 square is 4. Next step, if I take the LCM, 2 is the LCM. If I take 2 as the LCM, 2 into 2 becomes 4. So 4 plus 1 divided by 1 plus 4. Now this 1 plus 4 cancels. What remains is 1 by 2. This is the required answer. Now let's look at the next sum. We have the next sum 2 to the power 7b minus 2a into 8 to the power 2a minus b divided by 16 to the power a plus b. Yes, there is no common base, but we know that 8 we can write it as 2 into 2 into 2, which is nothing but 2 to the power 3. 16 we can write it as 2 into 2 into 2 into 2, which is nothing but 2 to the power 4. So nothing but 8 and 16 we can express as the multiples of 2. So I can rewrite once again as 2 to the power 7b minus 2a as it is. 8 I can write it as 2 to the power 3 to the whole power 2a minus b, let it be as it is, divided by 16 as 2 to the power 4 to the whole power a plus b. Now before I use the common base concept, let me just simplify the powers. So I can write it as 2 to the power 7b minus 2a into 2 to the power 6a minus 3b divided by 2 to the power 4a plus 4b. Now in the numerator as well as in the denominator we have the common base, that is 2. So let me write the common base 2 only once, whereas the numerator powers will be addition, means we have to keep the same signs, whereas the denominator terms powers will change their signs. So we get minus 4a and minus 4b. Okay. Then we have 7b minus 3b will be plus 4b minus 4b. So all these three terms get cancelled. Then we have minus 2a plus 6a is plus 4a and minus 4a is cancels. What remains is 2 to the power 0. 2 to the power 0, that is because the cancellation is with respect to the addition and subtraction. So anything to the power 0 is always equal to 1. This is the required answer. Let's look at the next problem then. The next problem we need to simplify this problem where we have x to the power a divided by x to the power b, its whole power a plus b, x to the power b divided by x to the power c, its whole power b plus c, x to the power c divided by x to the power a, its whole power c plus a. Now the first step what I can do is the innermost terms I can simplify. So what I can observe in the innermost term is the same base. So x let me write only once and it is division, so it will be a minus b. The outer power a plus b, let it be as it is. If I look at the next term, so x to the power b minus c, so the outer power b plus c will be as it is. Also for the next term x to the power c minus a, the outer power c plus a will be as it is. Now if we observe in each term the powers are of the form a plus b into a minus b. Each power is of the form a plus b into a minus b, and we know that a plus b into a minus b is nothing but a square minus b square. Let's apply this formula over here. So what we get is x to the power a square minus b square into x to the power b square minus c square into x to the power c square minus a square. The next step what we can observe is the common base. X is the common base, so let me write only once, and it is repeated with respect to the multiplication. That means the powers we need to add. We need to keep the same signs. So powers will be a square minus b square plus b square minus c square plus c square minus a square. Now plus a square and minus a square get cancels. Minus b square plus b square cancels. Minus c square plus c square cancels. What remains is x to the power 0, and which is nothing but equal to 1. Now let's look at the next problem. We have the next problem. Prove that x to the power a divided by x to the power b, its whole power a square plus ab plus b square, x to the power b divided by x to the power c, its whole power b square plus bc plus c square, x to the power c divided by x to the power a, its whole power c square plus ca plus a square is equal to 1. Since we have the question prove that, we need to start from one of the side and the answer need to be the other side. So let me begin with the left side and let me simplify it and let me get the answer as the right side. So let me write down the left side first. On the left side what I have is x to the power a divided by x to the power b, its whole power a square plus ab plus b square. The next term what I have is x to the power b divided by x to the power c, its whole power b square plus bc plus c square into x to the power c divided by x to the power a, its whole power c square plus ca plus a square. Yes. Now first let me look at the innermost term x to the power a by x to the power b. Same base with respect to the division, so I can write it as a minus b. To the whole power a square plus ab plus b square will remain the same. For the next term x to the power b minus c to the whole power b square plus bc plus c square will remain the same. The next term x to the power c minus a to the whole power c square plus ca plus a square will remain the same. Now if I look at the each term and its power, the powers are of the form a minus b into a square plus ab plus b square. Each term has the powers of the form a minus b into a square plus ab plus b square, which is nothing but a cube minus b cube formula. So let me apply this formula everywhere over here. So what I'm going to get for the first term, it is x to the power a cube minus b cube. For the second term, it is x to the power b cube minus c cube. For the next term, it is x to the power c cube minus a cube, which is nothing but equal to repetition of the same base. So let me write only once, that would be x to the power a cube minus b cube plus b cube minus c cube plus c cube minus a cube. Now let me cancel the powers. A cube and minus a cube cancels. Minus b cube plus b cube cancels. Minus c cube and plus c cube cancels. Cancellation with respect to the addition and subtraction. So what remains is x to the power 0, which is nothing but equal to 1. This is the required answer. Now let me look at the next problem. I have the next problem. If a to the power x is equal to b to the power y is equal to c to the power z and b square is equal to ac, then show that 1 by x plus 1 by z is equal to 2 by y. Now we have the two given condition. The first given condition is a to the power x is equal to b to the power y is equal to c to the power z. So let me use the first given condition, and that is a to the power x is equal to b to the power y is equal to c to the power z. They have given that these three terms are equal. Since they have given that these three terms are equal, let me take these three terms are equal to some constant k, where k is some constant. Okay, since they said these three terms are equal, I will take it as these three terms are equal to some constant k. Now let me take them separately. So a to the power x is equal to k, b to the power y is equal to k, c to the power z is equal to k. So that will be next step. Let me shift the powers to the other side. That I'm going to get it as a is equal to k to the power 1 by x, b is equal to k to the power 1 by y, c is equal to k to the power 1 by z. What I did is I shifted the powers on the other side. That is nothing but dividing the powers by x for the first term. For the second term, dividing the powers on both the side by y. And for the third term, dividing the powers on both the side by z. So this is by using the first condition. Now let me use the second condition. The second condition given is, let me consider the second condition given, which is b square is equal to a into c. What we can observe is we have b here, we have a here, and we have c. And we already know the value of b, a, and c. So let me replace those values here. So b I have as k to the power 1 divided by y. Let the whole power 2 be as it is. We have a as k to the power 1 by x. We have c as k to the power 1 by z. So that is nothing but k to the power 2 by y. So just multiplication of the powers, that's equal to same base is repeating. So what I can do is I can add the powers. Now what we can observe is the same base on both the side and it is equated. Whenever the same base is equated, we can always equate the powers. So I can write it as 2 by y is equal to 1 by x plus 1 by z. Now if I just concentrate on the given question, that is show that 1 by x plus 1 by z is equal to 2 by y, that is exactly what I got it here. So this is the required answer. Let me look at the next sum. We have the next sum. If 2 to the power 1 by a is equal to 3 to the power 1 by b is equal to 54 to the power 1 by c, then show that a plus 3b is equal to c. This is also the similar type of the problem what we solved previous one, but only one condition is given. Using this condition itself, we need to solve. Okay, so I have 2 to the power 1 by a is equal to 3 to the power 1 by b is equal to 54 to the power 1 by c. And they said these three things are equal, so let me take them as equal to some k. Let me take them as equal to some k. Okay. Now let me take them separately. 2 to the power 1 by a is equal to k. 3 to the power 1 by b is equal to k. And 54 to the power 1 by c is equal to k. Once again, let me shift the powers to the other side. I get 2 as equal to k to the power 1 by a, 3 as equal to k to the power 1 by, k to the power b, and 54 is equal to k to the power c. This is what I get. Now, we need to use these three conditions in order to get this particular answer. Okay, now what we can remember over here is we have the three digits, one is 2, one is 3 and one is 54. Out of these three numbers, let me make use of the biggest number, and that is 54 is equal to k to the power c. Let me make use of this first. Now, let me try to express this 54 as the product of 2 and 3. Let me try to express this 54 as the product of 2 and 3, which I can write it as 2, 54 as 2 into 3 to the power 3. That is nothing but is equal to k to the power c. That is nothing but is equal to k to the power c. 54 I can express as 2 into 3 to the power 3 is equal to k to the power c. Now I already know the value of 2, which is k to the power a. So let me replace into I already know the value of 3, which is k to the power b to the whole power 3. That's equal to k to the power c. Let me simplify in one more step. K to the power a into k to the power 3b. That's equal to k to the power c. Now, here on the left, what I can observe is k to the power a into k to the power 3. 3b, same base, I can add the power. So, it will be k to the power a plus 3b. That's equal to k to the power c. Same base equated, so we can just equate the powers. That would be a plus 3b is equal to c. Now if I observe the answer, they told us to prove that a plus 3b is equal to c, and we got the same. This is the required answer. Now let me look at the next problem. I have the next problem to solve. 3 to the power 2x minus 10 into 3 to the power x plus 9 is equal to 0. The meaning of solve is nothing but to find the value of x. So now since I want to find the value of x, let me rewrite this particular equation as 3 to the power x to the whole power 2 minus 10 into 3 to the power x plus 9 is equal to 0. I just repeated the same equation again, but one simple step I did here. Now, before proceeding to the next step, what I can observe here is 3 to the power x. So let me go for a substitution. Let me put 3 to the power x is equal to some other letter. Let me take it as equal to say some y. So if I take 3 to the power x as some y, I am going to get it as y square minus 10y plus 9 is equal to 0. Clearly, we can observe a quadratic equation, means we can perform the factorization. Y square into 9 will give me 9y square. So I need to look for two numbers whose product is 9y square and the sum is minus 10y. And those are 9 and 1. So if I multiply 9 and 1, I will get 9, but the product needs to be minus 10. For that reason, I need to go for minus 9y and minus y. So I will get it as y square minus y minus 9y plus 9 is equal to 0. Now combining the first two, taking common y, So I'll get y minus 1. Combining the next two, taking common minus 9 as the common, I get y minus 1. That's equal to 0. I can observe y minus 1 common. So let me take y minus 1 common out. What remains is y minus 9. That's equal to 0. That says either y is equal to 0 or y is equal to 9. But the question asked to solve for x. Now since the question is asked to solve for x, what I can do over here is I can replace the value of y in terms of x. That is nothing but we have taken y as equal to 3 to the power x. So 3 to the power x is equal to 1. Our intention is to find the value of x. X is in the power. In order to find the value of a power, we need to make sure that the base on both the sides need to be same. In order to find the value of the powers, we need to make sure that base on both the sides is same. So on the left, what I have the base 3 to the power x. On the right, this 1, let me write it as 3 to the power. So in order to get as 1, I can write it as 3 to the power 0. So now since the base is same, I get the value of x as equal to 0. This is one of the value. Now let me look at the second value. Y is equal to 9. So I can write it as 3 to the power x is equal to 9. Now in order to get the value of x, 9 I can express as 3 to the power 2, which is nothing but x is equal to 2. This is the required answer. So these are the two possible solutions for x, that is either x is equal to 0 or x is equal to 2. Now let's look at the next problem. If x to the power 5 by 3 minus y to the power 1 by 3 minus z is equal to 0, then show that x to the power 5 minus y minus z to the power 3, its whole power 3 is equal to 27 x to the power 5 y z to the power 3. Yes. This is the if condition and this is show that condition. So we need to begin with the if condition. So let me consider x to the power 5 by 3 minus y to the power 1 by 3 minus z is equal to 0. Now, ultimately the answer is in terms of whole cube to the whole power 3. So, I get one idea that I need to cube on both the side. I need to cube on both the side, cubing on both the side. But on the left, there are three terms. So, it's little difficult when there are three terms. So, what I can do is, I can shift one of the terms to the other side. So I will keep x to the power 5 by 3 minus y to the power 1 by 3 on the same side, whereas z I will shift it to the other side. Now let me go for cubing. So if I go for cubing on both the side, what I get, x to the power 5 by 3 minus y to the power 1 by 3, its whole power 3 is equal to z to the power 3. On the left, I have x to the power 5 by 3 minus y to the power 1 by 3 to the whole power 3. That means I am supposed to apply a minus b the whole power 3 formula, which is nothing but a cube minus b cube minus 3ab into a minus b. This is a minus b the whole cube formula. Let me apply the same formula. That would be x to the power 5 by 3, its whole power 3 minus y to the power 1 by 3 its whole power 3 minus 3 times of x to the power 5 by 3 into y to the power 1 by 3 into x to the power 5 by 3 minus y to the power 1 by 3, that's equal to z to the power 3 as it is. Let me simplify the left side. X to the power 5 by 3 into 3 gives me x to the power 5 minus y to the power 1 by 3 to the whole power 3 gives me y minus 3 into x to the power 5 by 3 into y to the power 1 by 3, let me keep as it is, whereas x to the power 5 by 3 minus y to the power 1 by 3 is nothing but z that we have in the previous step. So let me use that over here. So I can replace it as z is equal to z to the power 3. Now over here, if you look at our final answer says we need x to the power 5 that I have. We need minus y, that also I have. Then I need minus z cube, which is there on the other side. So let me shift this z cube to the left side. Okay, so that I can write it as x to the power 5 minus y minus z to the power 3, that's equal to 3 into x to the power 5 by 3 into y to the power 1 by 3 into z. So now once again if I compare, the left side almost looks the same, but one thing is missing is whole cube. So since whole cube is missing, let me go for cubing. So cubing on both the sides. So if I cube on both the side, x to the power 5 minus y minus z to the power 3, its whole power 3 is equal to 3 into x to the power 5 by 3, y to the power 1 by 3, z its whole power 3, cubing on both the sides. Now my left side matches exactly, but I need to simplify with the right side. The power 3 will go to each and every term on the right. So 3 to the power 3 will give me 27. X to the power 5 by 3 into 3 will give me x to the power 5. Y to the power 1 by 3 into 3 will give me y. Z to the power 3. So this is what I get after simplification, and this is the required answer. Let's look at the next sum then. We have one more solve problem. 5 into 5 to the power 2y minus 26 into 5 to the power y plus 5 is equal to 0. Solve means we have to find the value of y. Since I have to find the value of y, let me write this as 5 into 5 to the power y to the whole power 2 minus 26 into 5 to the power y, let it be as it is, plus 5. Now for the further simplification, I will go for the substitution. So let me put 5 to the power y as equal to some other letter, let it be equal to some x. So it will be 5 into x square minus 26 into x plus 5 is equal to 0. We can observe a quadratic equation. So 5x square into 5 gives me 25x square. So I need to find the two numbers whose product is 25x square and sum is minus 26x. Those are minus 25 and minus 1. So which will give me plus 25x squared and minus 26x. So I can write it as 5x squared minus 25x minus x plus 5 is equal to 0. Now combining the first two, taking 5x common out, what remains is x minus 5. Now next two, there is no common, so I have to take minus 1 common out. So what remains is x minus 5. X minus 5, that's equal to 0. So x minus 5 is common now, 5x minus 1, that's equal to 0. So the values are x is equal to 5 or x is equal to 1 by 5. So since I have to find the value of y, 5y is equal to y, 5 will give me the value of y as 1, or 5y is equal to 1 by 5 will give me the value of y as equal to minus 1. So these are the required answers.